Last week I did something I hate. I cleaned the house and more specifically the window. In general, this is something that I do twice a year, in spring and at the end of the summer, more or less. And since I live alone and I do not have a cleaning lady, I have to do it by myself. Of course, I know that you don't care about it, but please follow my reasoning because there's a logic. I know it's weird, but believe me, there's a point in that. Why I'm telling you all this? Also, by the way, giving you personal information about my private and home life. Well, this happens obviously because I'm mentally unstable, but also because I'm especially obsessed with all those halos that appear when I clean the window. Think about it. The product, the cleaning cloth, or even better, a newspaper. Someone told me that is very effective, trust me. The problem is that these are moving halos. The more you rub and the more you get nervous because you could ideally never stop. Anyway, I would be tempted to tell you some solution I found, but for now it's better to introduce the subject of today's episode that, what a coincidence, is going to be about those halos that form on the raw ceramic support during the drying phase and so within the dryer, and that can remain visible even after the firing cycle. What is behind this phenomenon, and without using cloth to wipe or newspapers, what kind of action must be taken to prevent it? I am Davide Trentini, and this is Apparently Invisible: Chemistry in Ceramics. As we know, the ceramic mixture after the atomization process undergoes during the forming phase to very high pressure that can be higher than 400 kilos per square centimeter, so to produce the raw ceramic body. The raw tile, even after the pressing phase, still contains a water amount that we could define as residual humidity that is around 5-7%. The presence of water is essential to provide the clay with the proper plasticity level that is required to model the raw tile under the presses. In other words, we could also say that the lack of residual humidity would be, at this stage of the process of course, a serious problem, because the raw materials that form the ceramic body wouldn't be correctly pressed. That said, if the presence of residual humidity allows you, on one side, to give shape to the ceramic support, on the other side, it's an issue or a problem because it negatively affects the tile's mechanical features that are necessary for the following application. What does it mean? It means that the water makes the raw tile more fragile, and so that it can be more easily attacked by the stress that may arise along the conveyor belts of the production line. Speaking about mechanical resistance, we know that to increase the resistance of a raw tile is necessary to remove the water from the system by means of a proper drying cycle that, thanks to the evaporation process, gradually excludes the water from the tile. We could also say more specifically that the water molecules, thanks to the drying process, must progressively move from the center of the ceramic body towards the other layers, evaporating and so allowing the system to bind, and therefore minimizing possible stress. In any case, the drying process must follow a precise procedures to avoid critical issues that may arise in the following steps of the production process. In particular, there are no problem when the atomized clay powder that is compacted by the presses complies with the formulation and is marked by proper amount of residual humidity, and also when the pressing action is uniform and without anomalies. And now the question is, how does the drying process take place? The drying process is carried out by means of dryers, of course, in which the raw tiles are placed on metal supports, also called roller stands or simply rollers, for a certain amount of time, until the value of the residual humidity is about 0%. As we have already said, the gradual warming inside the dryers leads to the migration of the water molecules that leave the ceramic body by evaporation. This process, however, in some cases can be not completely homogeneous over the entire surface of the tile. What do I mean? I mean that the parts of the ceramic body that rest on the roller stands may be marked by a different evaporation time and modes, we could add, with respect to those areas of the tile that do not touch the metal parts of the dryer. This different evaporation process that takes place in the lower and upper parts of the tile, in some rare cases, produces longitudinal bands or stripes that may remain visible even after the drying cycle. Basically, there are more or less brilliant halos that in extreme cases, and this must be underlined, in extreme cases, despite the following application of inks and glazes, may persist and be visible even after firing. The problem appears especially with technical ceramics production or in case of non-massive application along the glazing line. And so, from a chemical point of view, what is the origin of this uneven brilliance of the surface? Well, the reason is mostly due to the presence of some specific anions and cation that are chemical species formed by one or more atoms that freely move within the mixture and that during the drying phase are carried by the water's migration process. Since they do not evaporate, these kinds of anions and cations tend to accumulate and concentrate unevenly on the surface, or even better, in some specific and defined areas. And of course, the areas with a higher concentration show a different degree of gloss, or brilliance, if you want. In general, all anions and cations that do not form insoluble salts within the system, or that are marked by a low mobility due to their conformation, do not chemically bind to the mixture and tend to be carried by the water to the surface. But let's step back and take a closer look with an important question. Where do these kinds of anions or cations come from? I don't want to simplify, but three are the most relevant. First, dispersant for ceramic mixture that are sodium silicate based. Second, the processed water. And third, the inorganic raw materials of the ceramic mixture. Speaking about the raw materials, we can say in general that the features of the clay, and more specifically their different plasticity, can affect positively or negatively the water migration to the surface, and of course, together with the water, also the migration of ions and cations. And this depends on the clay's ability to retain or control the movement of the water. So, if this is the scenario, what kind of action can be taken to manage or prevent a problem that, even if it's infrequent, is not as rare as you might think? Okay, firstly, it is necessary to check the timing of drying cycle as well as the homogeneity of the temperatures and the heat within the dryer. The proper setup of the industrial plant is, in this regard, an important precondition to prevent the issues. If the problem persists, even in case of a proper setup of the dryer, a chemical intervention is necessary, so to eliminate the problem at its roots. In this regard, for example, it could be important to study and check the dispersant agents used in grinding phase. Why? Just because most of these chemicals are based on sodium silicate, that is a chemical compound completely water-soluble, and that, as we already seen, represents one of the origins of the problem. So, we are saying basically that the choice of the dispersant that has to be used is very significant. For example, to select a product marked by a low solubility means that its active ingredients, that is, ions and cations, with a residual humidity content of about 5-7% are only partially transported by the water during its migration and evaporation process. And this, of course, it gives you an idea of how important the formulation of a dispersant agent is, and more generally of all chemicals, because depending on the formula we can obviously have a good or bad results. But let's go on. It is also important to pay attention to the chemical composition of processed waters. Why? After a careful study of their features, it's important to check the presence of those anions and cations that can be responsible for the halos, that, as we said, can be visible even after the frying process. What does that mean? It means that it would be great to limit the presence of anions and cations of inorganic origin that tend to create soluble salts within the processed water. In this respect, even if the water electrical conductivity is not a guideline to precisely identify or classify the kind of anions within the water, the check of its values, of the electrical conductivity of course, can however give you information about a possible high contents of ions. If this happens, it is usually possible to act by cutting the processed water, that means adding mains or groundwater to reduce and decrease the action of the ions. And finally, there is another option to consider that can contain the problem, but this option is for sure extreme and difficult to put into practice. What are we talking about? We could act on the formulation of the ceramic mixture, for example by using or increasing clays able to retain water and so the ions, or at least to slow down and standardize the migration of ions and cations. For example, clays marked by a higher plasticity value, such as bentonite, absorb and retain much more water, also releasing it more slowly, and so promoting a more calibrated migration of water and ions. And with this extreme solution, even this episode has come to an end. As we have already said, the topic we have addressed is not very frequent, but I think it was useful to learn something new about the ceramic mixture. As usual, I take this opportunity to remind you that the previous episodes are available not only on the main platforms, such as Spotify, Apple or Google Podcast, but also on our app, in which you can find other contents and that you can download for free on Apple Store or Google Play. You can find it by typing ZMS Ceramco, CERAMCO.IT, or Apparently Invisible. I apologize for giving you a rather non-professional image of myself, because I'm sure that starting from today you will always think about me standing on a ladder and cleaning the windows. I promise that in the future I will not give you personal information anymore. Maybe. See you soon.